and how much cross-sectional area and at what point of the nozzle it will be added is discussed in this theory. That is the area for area method. Now, some material has been removed. Okay, some material has been removed from the cell wall. A hole is made. Now, that material is compensated at different locations of the nozzle. It may be below the nozzle, it may be the top of the nozzle, or it may be along the horizontal axis and vertical axis, and if needed a reinforcement pad is also included. Okay, so you can see here a reinforcement pad. Okay, this is the vessel or pipeline, whatever, and this is the nozzle, and also to provide or giving the more strength of the material, a reinforcement pad is also given here. So this is the purpose. And if you understand the different meaning, then it is very easy, because the expression for calculating the value of x, okay, then the value of a1, a2, h1, h2 is all given. Just you need to understand, it is very easy that to understand the notations applied in this figure. Now, these are the design process. Okay, so all the values is given, t, tn, what is t, tn is already given here. It is here. What is a1, a2, a3, a4? The area you remove for making a nozzle, okay, is attached at different four places. One, and A1 is the total area of excess thickness in the vessel cell A1. Okay, in the vessel cell A1, where is A1? A1 is here. Okay, horizontally. Okay, along the parallel to the vessel axis. A1. Okay, then what is A2? Is a total area of excess thickness in the nozzle wall. So A2 is the nozzle wall vertically, here and here both sides. Okay, it is a circular. So A1 and A1 and A2. Then other is the A3. What is the A3? Is the inside extension of the nozzle. Inside extension of the nozzle. So where is the A3? A3 is here. So inside extension. Okay, it is situated within the vessel. And last is the a reinforcing pad. Okay, if also needed, so reinforcing pad is fixed outside of the vessel. So these are the four areas you can add. So now let's solve the problem again from the starting. So let's see. Hmm. So let's see. You write it. So I am solving for the even values. So from the problem for the cell, Okay, it is given that inside diameter of the cell is 600 millimeter and cell thickness given 20 mm. And for nozzle, okay, its inside diameter, that is the small di, equal to 250 mm, nozzle thickness 15 mm, and also H2 value given as 15 mm. Okay, inside pressure 2.75 megapascal, yield stress 220 Newton per millimeter square, corrosion allowances 3 mm, welding efficiency 90%, and factor of safety is 1.4. So these values are given. Now, if the reinforcement pad is needed, so for reinforcement pad, the thickness should be 12 mm. It is given also. Anyway, now what is the allowable stress? At first, we have to calculate from the yield stress. So yield stress divided by the factor of safety, and this is 220 divided by 1.4, and it comes around 157.14 Newton per millimeter square. So up to this, no problem, I think. So please note down. Now the required cell thickness, what should be the required cell thickness? Required cell thickness, we apply the formula. Therefore, required cell thickness TR. Required cell thickness is needed PI DI to allowable theta minus PI. 2.75 1600 to 157.14.9 minus 2.75, and this is coming around 2.45 millimeter. Okay, now what is D? D is the inner diameter of nozzle. Inner diameter of nozzle. Inner diameter of nozzle in corroded condition. In corroded conditions. That means D equal to Di plus 2 into Ca, and that is equal to Di, you know, 250, that is 2 into 3, that is 256 millimeter. So D is no. Now, what is the amount of material removed for the nozzle? So next we have to find what is the area removed, area of removed material. So A equal to area of removed material for making nozzle. So That is the AD into TR. Okay, so inner dia of nozzle, that one into the TR, that is the cell thickness, liquid cell thickness. So 256 into 15.71 and 402176 millimeter square. So this much area of material is removed. Now the limiting dimension x. X may be equal to D, that is 256 mm, and maybe di by 2 plus T plus Tn minus 3Ca. Put the value, that is 125 plus 20 plus 15. Okay, minus 3 into 3, 9. So that is 151 millimeter. So which value we will take? Which value we will consider here?
256.
250.
Q? Because?
Sir, it is no.
It's more.
So therefore, the value of x consider 256. Now H2 is given. Okay, and H1 similarly you calculate from both the expression. Two 2.5 into T minus Ca और एक है H1 equal to 2.5 into Tn minus Ca. So for this one, that is 20 minus 3, and for this 2.5 into 15 minus 3. So that is 42.5 mm and that is 30 mm. ठीक है. So H1 कौन सा वैल्यू लेंगे?
30 mm, sir.
30 mm. And H2 given as 50 mm. Now A1. Now excess thickness in the vessel cell. Excess thickness in the vessel cell. A1. A1 is the excess thickness in the vessel cell. So the expression is that this one value So A1 2x minus d into t minus tr minus ca, that is 2 into 256, d means 256. So is it right? Yes, 256, 256. And 20 minus 15.71 minus 3 equal to 330.24 millimeter square. Similarly for A2, that is the excess thickness in the nozzle wall equal to 2H1 into Tn minus required nozzle thickness minus Cl, that is 2 into 30, that is 15 minus 2.45 minus 3, it is 753 millimeter square. Okay, for odd roll number, okay, for odd roll number, it will be 663.65 millimeter. For odd roll number, A1 will be 322.58 square. Now A3. A3 is the inside extension of the nozzle. So A3 will be inside extension of nozzle, that is equal to 2H2 Tn minus 2Ca, that is 2 into 15, 15 minus 2 into 3 equal to 270 millimeter square. Now A1 plus A2 plus A3. A1 plus A2 plus A3 is 330.24 plus 553 plus 270 millimeter square equal to 1173.24 millimeter square. Now for the odd number A3 will be, A3 बताओ क्या होगा? Pawnee, A3 का value बोलो. What is the value of A3?
330, sir.
30, sir.
330, very good. Then A1 plus A2 plus A3 add करो.
Yes, sir.
It is around
1380.88.
1316.23. Anyway, whatever. So, if we see the nozzle now, suppose this is your pressure vessel. Suppose this is your pressure vessels, and a nozzle is this one. So, and let us use another color like this one. And A1, you have given the excess thickness in the vessel cell. So here is A1. So you provide A1 means 330.24 millimeter square area here along this. Okay, fine. You are making or giving more cross-sectional area. Okay, I am drawing it little bit, making it little bit thicker for understanding. It's not like that. And A2, you have given A2, okay, in the nozzle wall. So in the nozzle wall, you also given the extra thickness here also. And A3 inside extension. So A3 make it different color like this. So A3 also like this. Now you see, you removed how much area? Is the value of A. How much area you have removed for making nozzle?
4021.76 mm square.
Very good. For even roll number. So, and even after giving A1, A2, A3, the still remaining area is A4 equal to A minus A1 plus A2 plus A3. So it is 4021.76 minus 1173.24 equal to 2848. What happens? Whatever you calculate it, whatever you calculate it. Okay, so here it is A4 equal to A minus A1 plus A2 plus A3 and 4021.76 minus 1173.24 equal to 2848.52 millimeter square. And for odd roll number, it is 2933.19. Okay. Now, this area you have to be added by a reinforcement pad. So, the next slide. So, a reinforcement pad is needed. If A1, A2, A3 is equal to AA, okay, then no reinforcement pad is needed. But here the removed area is more than that of the added area A1, A2, A3. So reinforcement pad you have to provide. And this is the reinforcement pad. So reinforcement pad like this you have to provide. Now, what is the area, cross-sectional area of the reinforcement pad? What is the cross-sectional area of the reinforcement pad? That is outside diameter of the pad minus inside diameter of the pad into thickness of the pad, that is given, that is equal to A4. Now, what is DI? You find out the value of DI prime. You find out the value of DI prime. You tell me.
We saw the screen is not visible.
Okay, okay, okay. I'm not sharing. So in the last slide, A4 equal to this one 2048.52 and for the reinforcement pad. So what is the value of the DI? You see the figure.